Scatterplot and correlation coefficient determined the overall pattern and any deviation in each of the 4 scatterplots below. For any scatterplot, we would need to describe it using the overall pattern. The overall patterns of a scatterplot includes the direction, whether it is positive, negative, upward, or downward, or neither, its form, whether it is linear or curvilinear, and its strength, how strong it is based on the form that we determined. We also need to determine any deviation from the scatter plot, and these are the possible outliers. When examining any graph, especially the scatter plot, we need to read the graph from the left to the right, from the left to the right. For the first scatter plot, as we move to the right, we see that most of the points generally move upward. And so we say that this scatter plot or this relationship has a positive association upward in this case. And so again, it has the positive association. It is linear, even though not all the points are on the line, but as the independent or the explanatory value increases, we see that the response value increases as well. And so if one increase and another increase, or one increase and another decrease, then it is a linear form. And so we say that this is a linear relationship. Although not all of the points are on exactly one line, but we see that if we were to draw the line through these points, then the points are very close to the line that we draw. In this case, we say that the relationship is strong or moderately strong. A relationship is perfectly linear if all of the points are on the same line. In most cases, in real practice, we are not going to have a perfect linear relationship. And again, in this case, we would say that it is moderately strong. It is pretty strong because most of the points can fit closely to the curve. Not perfectly, but close to the curve. For the second scatter plot, we see that if we move to the right, generally the points seem to be falling. The values seem to be falling. This can be a linear relationship as well. Remember, for a linear relationship, we move to the right. If the points generally move up or move down, then we can say that it is a linear relationship, one direction only, all the way up or all the way down, generally. And so for the second scatter plot, we say that it has a negative association because one goes up, one increases, the other one goes down. It has the downward association. And it is linear, approximately linear. However, if we were to draw the line that go through most of these points, then the points at the time are farther away from the line that we draw. And so we say that this relationship, this linear relationship, is very weak. For the third scatter plot, as we move from the left to the right, we can't really make out whether the points or the data values are going up or going down. And so in this case, we would say that it has no direction at all, no general direction. And since it's at no general direction, we cannot figure out the form. It is not linear. We can't really generally go up or go down. It doesn't fit in any non-linear graph such as parabolic, exponential. And since we can't figure out the form, we would say that there is no relationship at all. Not only there is non-linear relationship, but there is no other relationship. For the last scatter plot, as we move from the left to the right, we see that the data values tend to go up at first, but then they go down. Since they both go up and down, this is not linear. However, we see that it fits the parabolic curve. If we were to draw the parabola through these points, then we see that this is actually a strong relationship, but not linear. So this is curvilinear or non-linear. For the scatter plot, to describe the deviation, we need to first draw the graph. If the points are close to the line or the curve, then there is no outlier. For the second graph, if we were to draw the line, perhaps there are a few outliers. And for the third one, since there is no relationship, we cannot find any outliers based on this. We can only get an outlier if we can determine the form of the scatter plot. And similarly for the last one, since most of the points are close to the parabola, we will say that there is no outlier. Once we determine that the form is linear, but only for linear relationship, we can determine the correlation coefficient R. The correlation coefficient R is only for linear. It does not work for nonlinear. The correlation coefficient R will tell us how strong a linear relationship is. A correlation coefficient of a linear relationship is a number between -1 and 1 inclusive. A correlation is negative if the linear relationship is negative or there is a downward negative association. It is positive if there is an upward positive association. This problem is asking us to match the correlation coefficient number with the corresponding graphs. We will do this through the process of elimination. There are 9 correlation coefficients and there are 9 corresponding graphs or scatter plots. So for the first scatter plot, if we were to draw the line that comes close to most of these points, then we see that the correlation coefficient has to be positive. For the second scatter plot, since the line is upward, the correlation coefficient is also positive. For the next scatter plot, if we were to draw the line that comes close to most of these points, then the line is going upward, so the correlation coefficient is positive. For the fourth one, it is difficult to determine. For the scatter plot 5, as we move to the right, the point generally fall, and so we would have to draw the line that is downward this time. The correlation coefficient has to be negative. For scatter plot 6, if we were to draw the line would go downward. The correlation coefficient is therefore negative. For the scatter plot 7, the line would go downward. The correlation coefficient is therefore negative. For scatter plot 8, the correlation coefficient is positive. And for scatter plot 9, the correlation coefficient is negative. Out of all of these correlation coefficient, both positive and negative, we see that with the scatter plot 9, we can draw a straight line that go through all of these points. This means it is a perfect linear form. The association is perfectly linear, so the correlation coefficient is either -1 or +1. But since this is a negative association, the correlation coefficient has to be negative, so it is -1. And so we would say that R equals -1 is for plot number 9. Similarly, for the correlation coefficient 1 positive, the line needs to go through all of the points and the line needs to go upward, perfectly linear, and that is the scatter plot number 2. And so we got rid of scatter plot 2 and 9 for perfectly linear. With the correlation coefficient close to 0, whether it is positive close to 0 or negative close to 0, there is no linear association, and the best scatter plot that would describe no clear linear association is the scatter plot number 4. And so for number 4, the correlation coefficient is 0.01, almost close to 0. That is why we could not figure out the relationship is upward or downward. For the correlation coefficient to be another -1, again, the points need to be on the same line, and we see that this can be scatter plot number 7. Note that for the purpose of this exercise, it does not matter whether we put 7 in the first -1 or 9 in the first correlation coefficient -1. There are two more negative correlation coefficients from the table. One is close to -1, pretty strong, and one is close to -0.5, moderately weak. There are two graphs with the negative association left, and we see that the relations in scatterplot 6 is stronger than the one in scatterplot 5. And so for the scatterplot 6, we would have to say that the correlation coefficient R is about -0.88. And therefore, scatterplot 5 has a correlation coefficient of -0.44. The closer to -1 or +1, the stronger the linear relationship. And again, the closer to 0, the weaker the linear relationship is. There are 3 more correlation coefficients left from the table, with one being very strong, 0.94. And we still have 3 scatter plots left, 3, 8, and 1. The strongest one out of scatterplot 1, 3, and 8 is scatterplot 1. It is because scatterplot 1 doesn't seem to have any point that is further away from the line, as opposed to scatterplot 8, there is a point that is far away from the line, and that point weakens the relationship. And so, the correlation coefficient for the scatterplot 8 would have been 0.75. The last one, scatterplot 3, then would have the correlation coefficient of 0.55.